Good morning, everybody. Welcome to this webinar of ClimateCamp on Scope 3, Category 1, Purchase Goods and Services. I'm first going to make sure that the people who are waiting in lobby can join. Before we get started and start the presentation as well as the demo, I want to quickly ask you guys if you can hear me properly, if you can hear me speak properly. There is a chat on the top of the bar of Microsoft Teams where you can quickly add if you can hear me properly. Okay, perfect. Then we can get started. Let me quickly share my screen. Ruben, can you confirm to me that you can properly see my screen?
Yes, can well see your screen and hear you perfectly. Thank you, Maarten.
Okay, perfect. Hello, everybody, and welcome to this webinar of ClimateCamp on Scope 3, Category 1. We're in the middle of summer, a bit after the middle of summer, so we're kicking off our webinar series again. Today, we're focusing on a calculation topic, a very relevant calculation topic, but also at the end of the presentation, at the end of the demo, we'll showcase which webinars we have planned in the future. Now, today we're talking about Scope 3, Category 1, Purchased Goods and Services. And when I say we, I am not alone. I am joined here today with Ruben Pelkmans, who is Head of Customer Success for ClimateCamp. Why did I involve Ruben? Because I like him as a person, but also because he is involved in this topic day to day. He has helped dozens of our customers do calculations for the entire corporate carbon footprint, but specifically the topics related to Scope 3, Category 1, he is one of our major experts in this topic. Myself, I am Maarten de Kroos. I am the marketing lead for ClimateCamp, and today I will take you through the theoretical aspects of Scope 3.1, and Ruben will take you through how we do it in ClimateCamp. So the agenda for today, first a short introduction to Scope 3 Category 1. We'll give a short overview. Probably you've all heard this before, but we'll reiterate it shortly. Then the definition of Scope 3.1, but primarily why is it so important to calculate this, the relevance to your corporate carbon footprint, as well as focus a little bit on the role of hierarchy within Scope 3.1. Then we'll focus on the common problems when calculating purchased goods and services. These we see with our customers, we see with prospects. These often surface when doing these calculations, which is the first part, collecting activity. Many things go wrong there. Finding the right emission factor is also a very delicate topic. And then we also have the problem when there is no emission factor. Then we'll move on to how to actually calculate purchased goods and services. I'll give you a step-by-step process we give our customers, but which different tools and consultants employ. And then Ruben will take you through very specific examples in ClimateCamp, how we help speed up this calculation for purchased goods and services and improve its accuracy. He will touch on these common problems and how we try to circumvent it. At the end, we also have a Q&A. There is in Microsoft Teams a Q&A section where you can post questions with regards to the presentation and the topic, or you can paste them in chats. Let's get started. So when we talk about purchased goods and services, this is the visual. I think everybody has seen this visual over 100 times. This is the GHG protocol depiction of how emissions are structured for an organization, where we have Scope 1, 2, and 3. Scope 1 having to do with direct emissions generated by the company itself in its own processes, where we have Scope 2, which are indirect emissions, which come from purchased energy, such as purchased electricity, heating, and cooling. And then we have Scope 3, the indirect emissions, or the value chain emissions, which are divided in upstream activities and downstream activities, which relates to everything that happens before your activities, your company's activities, and everything that happens afterwards. Now, as you see, I've highlighted purchased goods and services here. Purchased goods and services is the first category and the first upstream category within Scope 3 calculations. Now, when we look at purchased goods and services, let me quickly do this. When we look at purchased goods and services, it covers all upstream emissions from the production of goods and services a company buys. That is the definition of purchased goods and services, which means we're talking about raw materials to packaging to outsourced services. Now, why, and this is what I mentioned in the beginning, why is purchased goods and services so important? Well, for manufacturers such as food manufacturers, chemicals, automotive, fashion, but also retailers, wholesale companies, this category usually represents the largest part of Scope 3. This means purchased goods and services for a lot of companies represents between 50 to 80% of total Scope 3 emissions. I've seen examples up to 90% and higher as well. But this also translates if Scope 3 for a lot of companies is 80% of their entire footprint. This means that purchased goods and services is responsible for 40 to 70% of the company's entire corporate carbon footprint. This means after you've laid solar panels and changed your cars to electric, the main focus should always be purchased goods and services because it is the biggest offender in your emissions profile. This is why it's so important to calculate and to act on it. Now, I talked about it in the beginning, hierarchy. When we start calculating purchased goods and services, we're talking about a lot of activity data. We're talking about huge Excels, millions of rows of information. So it becomes very important to structure the data. This will become relevant when you've done the calculations and when you have a view of your emissions profile. But it also helps spot problems before you do the entire calculation. Now, in practice, most companies group Scope 3 Category 1 in a couple of large groups, which dominate your footprint. So what we often see is that it gets divided into raw materials, into packaging, into purchased services. So large groups for these activities. And then we drill down. Now, why do we drill down? We either drill down into product groups or into relevant stakeholders. And what do I mean with that? For example, you have raw materials. I have sugar, I have grain. Why do we drill it down onto this level? Is because there are different people in the organization responsible for these product groups. So you want to help the people, the category managers responsible for sugar, to have a good idea of what the emissions are that are related to sugar. Or when we talk about organizational units, you have a Europe entity, you have a US entity. It will be relevant that you collect data at some point from these different entities. Well, then you will also need to hold certain people accountable, the plant manager for the US, the purchase manager for sugar in the US, to deliver the appropriate data. So splitting purchase goods and services into major groups and then into product groups and organizational units will not only help you in the data collection process, but it will also help you afterwards when you can hold stakeholders accountable for the emissions within their responsibilities. Now, common problems when calculating purchased goods and services. There are three major problems, and the first comes before you actually even start calculating, which has to do with collecting of activity data. Now, the first common problem is misalignment between stakeholders. What does this mean? You, as a sustainability manager, you need certain data, but you need it from other people. You need it from a plant manager, you need it from procurement, you need it from an ERP tool, you need to get it from other places. So it needs to be really clear what you need, what are the data points you require, and what is the structure they can deliver it to you. When this isn't clear, mistakes happen. And I will showcase this with an example. When collecting activity data, it's really important to specify which data points you need. For example, depending on the calculation methodology, if you choose, for example, spend-based or a hybrid or an activity weight-based methodology, you will need different data points. For the people who this is new information, spend-based and activity weight-based are different methodologies. A hybrid is one that combines both methodologies, where spend-based is a much more high level, which needs less data points. But activity weight-based is much more specific, highly accurate, but takes a lot more effort and a lot more granular data. Now, here you can see the data points you need. You need supplier name and ID, you need product group and ID, organizational unit, reporting period. This is the same for all methodologies. But for spend-based, you just need the amount spent on a certain activity, on a certain purchased good. Whereas if we look towards activity weight-based, you need the amount spent. It is optional, it's not required, but specifically you need the quantity purchased. But quantity purchased can be in kilograms and liters and units. If it's in units, you will need to convert it to a certain weight. So you need conversion factors. Do you know how many units weigh how much? Maybe you still need to weigh this amount of units to be able to convert these values. So you need this for activity weight-based. And maybe you need primary supplier data, which are related to these purchases. So if these data points are not clear, if the stakeholder does not know, I need to deliver these data points for these entities for this reporting period, mistakes will happen. The second common problem or other common problems are weights are wrong, commas are wrong, cells are empty. Now, what happens, data corruption, if you ever worked in BI or in data corruption always happens. Is it either through human error, somebody inputs something wrong, or because an export goes wrong? These things happen very frequently. Then you will have data corruption in your file. So it could be that your US entity delivers you the wrong data because something went wrong. Then you need to be able to identify these gaps. What you generally do is auto-detection of missing fields and wrong values. You can do this in Excel to some extent, but a higher complexity of detecting values is not always as easy. So it says like, here is a cell that is empty, we need data for this, or here the format for this cell is wrong, so it needs to be updated. That is a first step, and it often happens, but the biggest problem is often that entire data groups are missing. Now, what does this mean? It means, for example, I talked about I purchase certain raw materials, I have sugar, I have grain. Well, oftentimes you could have that for a certain reporting periods, data is missing. Export went wrong, we don't have 2024 purchase grain. Or the US entity, because they use a different tool, the export works differently, we're missing sugar purchases. So you need to be able to identify, do we have all the raw materials? Do we have all the reporting periods? And that can only be solved with contextual analysis. Contextual analysis is actually taking the Excels you receive and creating visual overviews. Visual overviews are graphs or like rotating tables which show, we don't have sugar for this entity and we know it purchases sugar. We don't have data for 2024 where we know we purchase sugar in 2024. Ruben at a later point will also give an example of this. The second point of contextual analysis is comparing it with historical data and contextual data. We often talk about increasing carbon maturity as a company. One of the reasons you do that is to improve your calculations year over year. Once you are in your second year, you have data to compare it to last year to see, the emissions for sugar are 5% higher, but that doesn't make sense because we bought 3 times more sugar. So building up historical data is an important element of improving calculations. And then you need to have a feedback loop with stakeholders, because when these data gaps happen, when data groups go missing, you need to check with your US entity or with your category managers or with whoever does exports from your tools to see what went wrong, how you can collect this data and enrich it in your calculation process. We see this happening, this happens weekly, not only when people do it themselves with tools, consultants. These are very common problems when handling large amounts of data. The second problem is finding the right emission factor. Now, finding the right emission factor, why is this so hard? Well, first off, access to high quality AFs is often paywalled. So emission factors are locked behind pricing tables, which means that you need to pay as a single company to get access to certain emission factors. That's why a solution is often working with a tool or a consultant, because we can spread the cost of these databases across multiple customers, whereas you need to pay for it alone to get access. You also need knowledge of the underlying studies and contexts. Emission factors are based on studies. You need to understand which studies they are based on, the context of the different parameters which relate to emission factor allocation. I'll give an example for aluminium. When you want to find an emission factor for aluminium, there are more than 10 emission factors. There are differences in, there's a global average, there's a regional average. You can have differences in system boundary. Was this a cradle to gate to grave, gate to gate PCF calculation, emission factor calculation? Production route, there are different ways to make aluminium. There are also different sources for using recycled aluminium versus primary or virgin aluminium. What energy mix was applied? Did they use grid electricity? Do they have solar panels? What allocation methods were used? Temporal version, was it a study from last year, the year before, even the year before that? Is this the most accurate emission factor? And then you also have spend-based emission factors and unit-based. So for aluminium, you have more than 10 emission factors, but what is also relevant is the spreads of the value. Here we can see there is a difference between 0.3 kilograms CO2 equivalent, kilograms per kilogram CO2 equivalent, and 16. Why is that? The more average you go, so the global average here is 16 kilograms, the less specific it is. So if you source aluminium from the European average versus a global average, you already reduce or you already import half to 1/3 of the emissions just by using a correct emission factor. So knowledge required of underlying studies and context is a common problem. As I mentioned before, temporal versions. So you need to every year search for updated values. New studies get published. There might be new research when it comes to aluminium in Europe. So you need to check when you do calculations each year to see if there are more relevant values. And then it's also a huge task to do this process, not just for one product group, but for 50, for 100, for 150. Now, what is the solution to this problem? A tool will use initial mapping by AI to speed up the process. I will very much emphasize AI is good to do initial allocation, to use geography, to use name, to allocate to emission factors in a first line, but you should always have a validation step by emission factors experts. AI misses contextual information, this knowledge of underlying studies, global warming potential, these elements to accurately validate the data you have mapped with emission factors. So you should always have an emissions factor expert. Is it the tool that you use uses emission factors experts, or you work with consultants? And then you need to have a feedback loop between company and the tool consultants. Why? Nobody knows your purchase goods better than your category managers or your procurement officers. So the makeup of what you source from where, how it is different, maybe studies from certain suppliers, you are the first line of information for this purchase goods data. The tool and consultant is just trying to find the most relevant emission factor. So you need to have a good feedback loop between yourself and the tool consultant to really improve this accuracy of finding the right emission factor. And then the third problem is there is no emission factor. We have tens of thousands of emission factors globally, but goods are very specific, and there hasn't been a study for every single raw material that exists in every region, for every production route, for example, or boundary. So then your suppliers need to do PCF calculations yourself. I'm not going to dive into this topic because PCF calculations is a whole webinar in and of itself, which is also why I gave one on this topic 2-3 months ago with Ruben as well. I'll, after this webinar, send a mail and I'll link this PCF webinar so you can watch it and see how you can help your suppliers with PCF calculations. But when there is no emission factor, you need to create one yourself, or your supplier needs to create one yourself. These are the common problems when calculating purchase goods and services. Have a good process for activity data collection, finding the right emission factor, and generating an emission factor when there is none. So what is the process for calculating Scope 3 Category 1? First, you start with the collection phase, and before you actually collect, you start with defining what do I need, where will it probably be, where do I need to get it. You need to inform your stakeholders of what you need. Plant manager of the US, I will need these data points. I will need it in this format. I'll give you a template Excel so you can format the data accordingly so we have less mistakes. You set up a collection system. Excels will go back and forth with missing data or with updated values. So make sure you have a proper way to communicate this information between you and the stakeholder you're talking to. And then you set up your emission groups according to a relevant hierarchy. Something I mentioned in the beginning, on product group level, on stakeholder level. Make sure this structure has been defined before you start, because it will give you trouble afterwards otherwise. Then we go into the analysis step before we go into calculate. For these mistakes like detection of wrong values, missing individual values, to do contextual analysis to see, are we purchasing sugar in the US? Are we missing reporting years to find these large data gaps? And then you will have feedback loops with the stakeholders who supply you the data. Third step is calculate. You find the relevant emission factors. You can do it yourself, but it will take a lot of time and you might lack the expertise to find the right emission factors. Or you can work with a tool or consultant because they specialize in this and they can spread costs of access to emission factor databases, for example. If you have none, or if your supplier cannot provide one, you need to create emission factors yourself, or your supplier needs to do so. The fourth step is validation. I mentioned it before. Validation is very important. You compare your data and your calculation outputs with different data points, preferably historical. So that is why building up reporting over years, improving your carbon calculations over years is very relevant, because I can then say, I purchased 5% more sugar last year than last year, but my emissions are ×3. Something went wrong. So validate with different data points. You can do it historical. You can also do it versus competitor. They might publish reports where they divide their carbon footprint according to the metric of their output, liters of a certain product or kilograms of a certain product, which helps you benchmark your results versus theirs. And I will stress this, external validation is key. Having somebody check your homework is always relevant and should always be considered. If you have to comply to CSRD or other regulations, you will have to have assurance. But if you are doing it before you have to comply to these regulations, you should still do it. Data and large data sets are very prone to mistakes, to errors, to gaps. Having somebody check your process, check if everything is correct, if nothing is missing, to do another contextual analysis, will make sure that you have the least amount of mistakes as possible, that you have the highest accuracy as possible, and that you can make decisions based on what actually happens, not some data that has been corrupted over time. That is how we do it with ClimateCamp, but also how prospects we talk to do it without a tool, for example. But now I want to go over to Ruben, who will go over this process, but show how we support our customers in the calculation process of Scope 3, Category 1.
Thanks a lot, Maarten, for this extensive explanation. I'll indeed show a bit more on how these topics are dealt with within ClimateCamp. If all goes well, everybody can see my screen now?
Yes, I can see your screen.
Great, thanks a lot, Maarten. You'll see that in ClimateCamp there is many different functionalities. Today we'll only focus on the calculate. It's important to note that there are also some functionalities available with supplier engagement. That's not a topic for today. Today we'll dive into the calculate section, and then more specifically the calculating of purchased goods and services. One of the first steps when using ClimateCamp is to create emission groups. So what are emission groups? Emission groups are actually the different divisions within your organization. You could see it a bit as your streamlined with financial reporting, where we will divide different activities of the organization among groups to gather data for. For example, we see here the raw materials, which in this example, we divide into different raw materials subgroups. The CapEx could be included, everything related to employee transport, energy usage, leasage, and transport. So actually, these are all different kind of activities for which you would need to gather data if you want to calculate a corporate carbon footprint. There are some additional categories which are not included in this example, but today we focus on the purchased goods and services, and in this example on the raw materials. As Maarten indicated, it's quite important. It's quite interesting to use internal reporting structures to gather data, as it allows to put clear responsibilities with clear owners on certain topics, be it category owners, for example, who could be responsible for gathering the data to do the calculations, managing carbon budgets, and make sure that those topics are owned. You will see that each emission group leaf, for example, here at the bottom, will be linked to a GHG category, in this case, purchased goods and services. This allows to do reporting within ClimateCamp, both in line with the greenhouse gas protocol, which is the international standard to do the carbon footprint calculations, as well as reporting on internal reporting structures. So in that sense, it's possible to have a GHG report, but also internal reports available. Once these emission groups so what's also very important is that during the onboarding process, ClimateCamp will guide and support our customers in setting up these groups, as it's often not that obvious which categories or which emission groups can be allocated to which scopes. So that's something that ClimateCamp supports in. Next to these emission groups, it's also important to set up the internal organizational structure within ClimateCamp. So as you will know, an organization can consist out of many different entities, and it can be important to allocate activities on an entity level. For example, in this example, we set up a demo company with sub-entities in Germany and Belgium, and within Belgium, there is different production sites which we have set up as well. This allows to do reporting on these entities and also to make sure that we have a good view on emission allocation per reporting entity. When we go then in the calculate and in the activity step, this is actually the place where you can do the calculations, upload data, allocate emission factors, and calculate emissions. On the left side, you'll find the emission groups, which we have talked about before, and we'll now dive into the raw materials. So as you can see in this example, we already uploaded quite some activities, and I'll now just take one to explain a bit which kind of data points we gather and how we work with that. So in this example, if we would edit the wheat, the first thing to, or maybe I'll actually create a new one that will make it a bit more tangible. So the first thing to select for an activity, first things first, there's different ways to upload data in ClimateCamp. It's possible to add activity per activity manual, or it is possible to upload activities using an Excel upload. I'll first go through the manual upload. That allows me to explain the different properties per activity. And then afterwards, I'll show you how the data upload works in ClimateCamp. When uploading a specific activity, the first thing is asked is the emission group. So that's the emission groups we talked to before. So for example, in this example, we could upload a wheat. We will be asked to allocate this towards an organizational unit. For example, this is an activity that a purchase that has been done by our Ghent entity. We'll give it a name. It's actually a regenerative wheat that we have purchased. We can give it an activity ID to do the matching with your ERP system, give it a specific product code, assign a supplier to this activity, give it a quantity. Okay, we'll take, for example, the tons. We can allocate a period towards the activity, making sure that we allocate the purchase to the right purchasing period, and then we can assign an emission factor. What's interesting to see is that, and I'm quickly looking here, for example, in this case, we have allocated a supplier, the supplier Agrivesco. In this case, it is possible, if the supplier data is known in ClimateCamp, to work with a supplier emission factor, which will be always a bit more accurate than an industry average. But usually we'll start with allocating an industry emission factor. As Maarten indicated, this is something that ideally is done by an expert. How it works in ClimateCamp, based on the data provided before, we will actually, in the backend, allocate a first emission factor. When our emission factor expert has validated that emission factor, this emission factor will be allocated towards the activity, allowing to do a validation on the customer side. So that's a bit how these industry emission factors are being allocated. What usually happens is that once an industry emission factor is being allocated, our customers will do a validation of the emission factor. If they see that it's not really a match towards the activity that has been created, then there is usually a communication between ClimateCamp and the customer to make sure the right emission factor has been allocated. So you should see the emission factor allocation in the following steps. 1, an activity is being created. 2, our AI will allocate automatically an emission factor. 3, our emission factor expert will do a validation of the automatically assigned emission factor. As a 4th step, our customer will look into the emission factors and see if that makes sense. Our customers have the best view on what the activities entail, so we'll be able to validate if the allocated emission factor is the correct one. If this is not the case, then ClimateCamp expert will provide an alternative emission factor available for this activity, making sure the right emission factors are being allocated. So that's a bit of the manual upload in ClimateCamp. What we see very often for bigger data sets is actually that Excel exports are being uploaded to upload data in bulk. So how can data be uploaded in bulk? It is possible to import data in ClimateCamp. So it's simple clicking the import data. We then need to select which kind of data we upload, as based on the different JG categories, different data points would need to be made available. So in this case, we are uploading purchase goods and services, which will bring us towards our upload wizards. In the first step of the upload wizard, the different data points which need to be filled in the import files are described. And it is possible to easily download an example. I quickly pre-filled an example for you. So this is an example where you will see the data points we just filled in with the manual creation. So the first topic to fill in is the emission group. We can then add a code to link towards our ERP system, add a product ID and a product name, add a quantity and a unit. It is possible to work with conversion factors. I'll talk about that later. It is possible to enter the currency and the cost, allocate a vendor, a start date, an end date, and organizational unit. So why do we use these conversion factors? What we often see, definitely when we are looking, in this case is only about raw materials, when we're looking at packaging, is that the weight of the packaging is actually not always known. Let's say, for example, I purchased a quantity of boxes. I will usually have in my ERP system that I purchased, for example, 100,000 units of a specific box, but I will not per se know the weight for these boxes. What we usually do in ClimateCamp is that we'll first, based on the currency and the cost, use a spend-based calculation to do the initial calculations on the corporate carbon footprint level. If we see that these 100,000 boxes, of which we do not know the weights, actually have a significant proportion of impact on the total carbon footprint, it is worth the effort to weigh the box so that we can convert the total number of units times the weight per unit. So let's say that we have 100,000 carton boxes. Each box weighs 300 grams. This allows us to translate the number of boxes into a weight, which will then allow us to have a more granular calculation than a spend-based calculation. As you probably know, if you do a spend-based calculation, the calculation accuracy will be a lot lower because, of course, the spend on a certain product depends a lot on specifics of the purchase, good negotiation, the type of box purchased, the relationship with the supplier, and so on. So if we see that a big proportion of the total emissions is related to activities which are spend-based, it's worth to look into the conversion to convert the units in a weight to then use a weight-based emission factor. So that's why it can be interesting to work with the conversion factors to translate quantity of purchase into a weight or volume-based calculation. Next to that, you also see that we ask to fill in the vendor name. It's an optional field, but why is it interesting to upload the vendor or allocate the vendor towards your activities? It is so that you could have a good view where the emissions among your vendors are allocated. As you might know, on average, 85%, or as Martin indicated before, on average, a very big part of the total carbon footprint is allocated in the value chain, of which a very big part is allocated to purchases. It's therefore, when we are looking into reducing carbon footprints, can be very interesting to know where these emissions are happening among my value chain. So for which suppliers are acting or generating these emissions, which in a later stage can be interesting to map out, okay, what is these suppliers are doing with their carbon footprint? Do they maybe have more sustainable alternatives available? So yeah, it can be very interesting to allocate activities towards suppliers to then know which suppliers are responsible for which parts of their carbon footprint. As Martin indicated before, what's also very interesting to look at is the completeness of the data. What we have seen in previous calculations is that sometimes the carbon footprint information needs to be gathered across different entities. These are different people responsible to gather these data points. So it's very important to do a quality check or at least a high-level quality check on the data that we have received. This can be in many different ways, for example, based on the currency and the cost, which you could map towards the financial data. If this is more or less in line, you will know that you received all data points. Next to that, what we often also do is actually generate a graph. That's something that we do together with our customers, which gives us a bit of a view on the different purchases across the different entities. So in this graph, you actually see which kind of product groups were purchased by which entities. So in this case, it's a simple example where we purchased different topics in Merksem and in Rotterdam, and we compare the purchases across the entities. In this case, for example, we see that the rye is actually has purchase in Rotterdam, but it seems there is no purchase in Merksem. So it might make sense to look a bit deeper. And actually, we indeed see that there is no data available for rye. So if this is not available, it could be interesting to validate if it's indeed correct that in Rotterdam, this product group has not been purchased while in Merksem it was not purchased, while in Rotterdam it wasn't. So it's another way of a high quality check to make sure that there is no data points missing. Also, the comma error pumps out here very often, very quickly as well, as it will result in a very high purchase of certain product groups compared to lower in other entities. If these don't make sense, often this comes out very fast out of these graphs and makes it easy to validate if the data is complete. If these high-level data checks are done, actually then we can start with uploading the data. So this can simply be done by going to the next step and uploading the file into ClimateCamp. You simply select the file from your computer, click next, and we'll try to upload then as well. Actually, the system now indicates that there is a specific column which is not matched, which is the ID. So the ID is a required field. So in this case, we called it code, therefore it was not matched. So it's possible to simply indicate this required field in the list. As you will see, if the name of the column is similar to the name that we expect, like in this case, we call it group, but actually it should have been product group, our AI will match it already to the right column, taking away the need of having a one-on-one match between the names of the columns and the columns itself. But if the name is quite different, then it's still needed to do a manual allocation.
If there is missing data cells, which I mentioned before, in the Excel, our wizard here will show there is this data gap which hasn't been filled in and highlight that for you.
Correct. So if we go here to the next step and we would click next step, actually we'll see, yeah, it will give me the same error as before. I allocate the action. So then our system will indicate that there's actually 2 rows not valid. So as Martin indicated, can then be interesting, and I'll see where I place you guys. Interesting to see which data is not valid. So we see that for this first row, actually the unit is missing. So here the unit is missing. It is wheat. Actually, I do know that that is expressed in tons. Then I could actually simply add this information here already and indicate that it's in tons. If my keyboard works with me, okay. And if the ton is filled in, then actually the line will actually disappear and only one row will be incorrect. For this row, actually what we see is that the organizational unit is incorrect. So there we'll need to click and select from a drop-down the entity for which is available. So if we know for which entity this should be allocated, let's say, for example, the maximum allocation, then we can indicate this. And then actually now all rows are correct and can be uploaded this way. We see very often that for smaller data sets, this is solved this way. Our customer with very big and large data sets usually will want to rectify this data in their ERP system where this data is coming from. So it is possible to do it during the upload. We have other customers who prefer to rectify this in their ERP system and then pull a new extract, making sure their ERP system is correct. If I would click import data, but it will mess up the demo account a bit, then all data will be made available in ClimateCamp, and then the emission factor allocation starts. So to go back to the approach, the first thing we did is collecting information. So it's collecting different data files. Then we'll analyze it by checking, okay, is the data complete for all entities and are there no weird purchases visualized by making a graph out of those. We then upload the data to do a second validation to make sure there is no required fields missing, like units, like organizational units, and so on. And we will then start with the calculation process. So what happens now in the background is actually that our AI will start to work and do initial allocation of the emission factors. For this, our AI uses around 50 databases, of which the most common ones, as you'll probably be familiar with, are the eco-invents, the Spheras, the Blancs, the Bilan Carbons, the Agribalise, and so on. But there is around 50 databases in general that are being used to find the right emission factors for these activities. Once this exercise has been done, this takes a couple of minutes. A notification will be sent to our emission factor expert, who will take a look at the data fields that we received and the allocation of our AI for the right emission factors. When this check has been done, we will send this information towards our customers, who will then be able to do a second validation on the work of our expert and our AI to make sure that, based on the knowledge that they have of the products that have been purchased, if the suggested emission factors match these activities. If they are happy with that, great. If there are, but usually you'll see that there are some activities for which they want to go a bit more specific, or where they see that the emission factor provided is actually not correct. So that's then something that our emission factor expert will rectify and propose a new emission factor alternative. As Martin indicated, in some cases we see that the emission factors available in the market are actually not sufficient. And if we see that for activities that make out a big proportion of the total carbon footprint, but there are no emission factors available to be able to do the calculations with, then we see that some of our customers will start a collaboration with some of their suppliers to calculate specific emission factors for these activities. We always recommend to only do this with activities that take, of course, a significant part of the total carbon footprint. So I think that's an important one to know. So once the calculations have been done, once the data has been uploaded, the emission factors are allocated, then actually we have a good view of calculations of the total for all the activities. It's then a matter of going to the overview to validate the calculations. In this graph, it's a bit screwed, so usually we'll see that purchase goods and services is a bigger part, but you have a good view on the scope 1, the scope 2, and the scope 3, and the primary data share used in these calculations. We'll then be able to see the emissions over year. In this year, there is only 1 year filled in, so that's only 2024. If there are multiple years filled in, we could compare the different emissions across the different years and actually be able to see also what the impact is of the top 15 products. So in this case, we see that the grain wheat is responsible for 12% of the emission, the German wheat 11%, and so on. So actually, the percentages are at the bottom. Actually, the German wheat is actually 11% for a specific wheat. So it's always interesting to look into the bigger emitting products, to look into the market if there is maybe more sustainable products, alternatives available. We could also see the emissions over the different emission groups and then also across the different suppliers. So in this case, we see that Butter Grains GmbH is responsible for 21% of my total emissions. So there it will become quite important to work with the supplier to make sure that they are acting on their carbon emissions. As Maarten indicated, it's also very interesting to compare your own carbon footprint with similar organizations. For that, we could use the Explore, where we can look for specific companies and then look into their carbon emissions. I hope this gives a bit of a good view on how calculations are done for the purchase goods and services. Yeah, and I think that's a bit what I wanted to present.
Okay, thank you, Ruben. I'll take over to close out the webinar. First, I want to ask, before I continue, if there are any more questions which relate to Scope 3 Category 1 calculation. It can have to do with ClimateCamp. It can have to do with like how you do it in Excel, problems you are running into, difficulties you are having when finding these emission factors. I'll give a couple of minutes now. If you have any questions, please do ask them. This is helpful for us as well, so we can better counter these questions when we talk to new prospects or customers, so we can help them in their calculation process. So if you have a question, please do ask it in chat or in Q&A right now. And then while you are thinking of a question, I'm quickly going to refer to what's going to quickly present like this. I'm going to go to the presentation. All right. I'm going to quickly reference that we have 2 upcoming webinars. As I mentioned before, we are going to do every 3 weeks a webinar on a topic related to Scope 3. These will have to do with either calculation topics, so PCF, Scope 3.1. We have one upcoming one which talks about up and downstream transportation. This will be on the 7th of October. This will go into all the different details with transportation routes, how to allocate certain emissions when you are lacking certain information, how you can make the most granular assessment as possible based on the information you get from your logistics providers. So this is a calculation topic, for example, on Tuesday, the 7th of October, but we're also tackling different topics in the webinar series. One topic is supplier engagement, so how it can help minimize operational risk and help you hit your reduction targets. As Ruben mentioned before, supplier specific data, emission factors, PCF data play a big role in how much emissions are generated in your Scope 3. So using supplier engagement can give you much more granular and highly accurate insights into your value chain and where emissions are being generated, and work together with them to hit your reduction targets. So this is a topic we're tackling within 3 weeks on the 11th of September, Thursday, the 11th of September. Further in the future, we'll also talk a bit more about reduction target setting and topics related to that. I'll quickly check if in the meantime there have been any questions. I don't see any questions in the Q&A, and I don't see questions in the chat. So that means the webinar was clear, and
or everybody fell asleep. That's another.
Or everybody fell asleep. But if there are any further questions, I will send a follow-up mail with the recording of this webinar, the link to the PCF calculation webinar, as well as upcoming events. If you have any more specific questions, you can always mail me at marketing@climatecamp.io, and I will be very happy to respond to any and all questions you might have. I want to thank everybody who was present today for the webinar, and I hope to see you next time in 3 weeks. Thank you very much.
Thank you.
Bye-bye.
Bye.